All right. Oh, for gosh sakes, you piece of crap. Shut up. All right. So anyway, today I thought we'd chat about 1.6, which is exponents and logarithms. Again, this is all review. It's just a matter of making ourselves good at it. So of course, what do we know? We know exponentials always look something like this. Ta-da! So if you have y equals a b to the x, it passes through the point 0, comma a. And specifically, well, if we have y equals b to the x, which is what we want to do here. And I say that because remember, exponents and logs are opposites of each other, inverses. So here's the dealio. If I just divide by a, I'm just going to write this step right here, is equal to b to the x. Oops, b to the x. What I end up with this basically is this, right? It's some y value, right? It's some value, right? And of course, the opposite way of writing this is writing it as the log base b of y is equal to x, right? We're just working backwards. And so anyway, so as I say, this equation here is 0, 1. So where it passes through, notice it goes into this quadrant, we have negatives and positives. In this quadrant, we have all positives. Well, the inverse, of course, is going to be mirrored over the line y equals x, meaning we're going to have negative positives. We're going to have the point 1, 0. And there it is. And so this is the log base b of x over here, right? And so that's what you got to remember to think about as you're doing these. You got to keep that in the back of your head. And of course, that should be fairly simple, I think. Log base 10. Remember, it's just or just log. That's the common log. And of course, why do we do common logs? Well, because our number system is base 10. So if you said that the log of, I don't know, let's just say some value x is equal to 2.19, what you know this is going to be 100. Well, okay, you know this is going to be, I should back it up. You know it's going to be between 100 and 1,000. And how do I know that? Well, because 10, which is the base, 10 to the second is a honey, and 10 to the third is 1,000. True that? And so when I look at this, I think, oh, it's closer. It's closer to 2.19 is. So I bet it's going to be closer to 100, and of course you're right. So if I just do this, 10 to the 2.19, I get the 1.54. And of course, this calculator doesn't have a button for log. It kind of does. You have to go into catalog, which is right there, stupid. And if you hit the L button, you can come down and you can actually find log. The log of 154 is 2.19. Yay! That's all that is. We know that to be true. Hey, what's the log of x? Sorry, if the log of x is equal to negative 2.75, well, wait a minute. 10 to the negative 2 is 0.01. True that? And 10 to the negative 3 is 0.001. So it's got to be somewhere between those two values. True? So if I plug it in, 10 to the negative 2.75 is 0.00177, which is basically what I said it was, didn't I? Okay. And so there you go. So common logs, we do use them, not as much as we used to. We use more the natural log now. Or if you prefer, which I don't, of course no one does, we just write it. It's the log base E. Remember, E is our guy, 2.718, yada, 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 yada. Remember, he is an irrational number, non-repeating, non-terminating decimal. Okay? And so that's that. Now, so if you said to me, hey, Mr. Grimm, I want to know how to solve this equation. So 100 is equal to 2.5 times 1.2 to the x power. Girl, I want to solve for x. Well, I know. So please excuse my dear Aunt Sally. And we're going this way to solve, yes? Is there any addition and subtraction to get rid of? No. but we can divide by this 2.5 and get 40. So in other words, we need to know is this. 1.2 to the what power is equal to 40? Well, I don't know, but we're going to figure that out. Groom, if we had a log base 1.2 power, it would give us the exact answer. Exactly, but we don't use 1.2. Are you with me? So instead, what we do is this. We say, listen, we're going to take the log of both sides. Again, whatever thou doest to one side, thou must also doest to the other side. So I take the log of 40 is the log of 1.2 to the x. Remember that? And then once you do that, remember the x can come out front. And so you get the log of 40 is equal to x times the log of 1.2. And that's a number, so if I divide that, I will get this. And so x is that. And you're like, wait a minute, Groom. But isn't that the same thing we would have gotten if we had done the ln, or the log, rather, of 1.2 of 40? It's exactly what it would have been. Wait a minute. So what you're saying is, Groom, that the log, well, I'm saying it with ln. You take the log of this guy divided by the log of this guy, you get the same answer? That's correct. Does it only work for natural logs? No, bro. In fact, it works for any base. So if you have the log base b of a, that is the log base r of a divided by the log base r of b. That is, the idea is it doesn't matter. What that r is doesn't make any difference. Now, I personally will use ln's most of the time. If I had a different calculator that had the log key on it, I might use the log key. I'm probably just going to use ln, okay, most of the time because it's right here on my calculator. So the ln of 40 divide by the ln of 1.2. And so I got 20.2, right? And you're like, Joe's like, Green, was that right? I don't know. Let's try it, Joe. Oh, yep, I'm right. Good for me. Obviously, it doesn't mean 1.2 times 20 means 1.2 times 1.2 times 1.2 times 1.2 times 1.2 20 times. Yes, that's the plan here. Okay? Excuse me. So we'll be doing that. Okay? This is what's referred to as the change of base formula. And again, 90% of the time, 95% of the time, I will end up with an equation that looks like this. I will end up with 40 equals 1.2 to the x power. I need to get that down. To get that down, I need to take the log in order to do that, right? Okay, so what do I do? Well, I can take the log. So again, I will either do ln of both sides or I'll do log of both sides. Doesn't make any difference. And again, if you had a calculator where you could throw in any base in there, then theoretically you could just do the log base 1.2 of 40. But here's what that doesn't tell me. It doesn't tell me how to work with logarithms better. It doesn't tell me how ln works, because when you go to most places, let's say you go down to study engineering in college or whatever, you take some math guy. Math guy waves his hand at this 100 miles an hour. Physics guy waves his hand at this and physics guy probably can't even tell you why it works. He just does it, and you're kind of like, what now? Well, blah, blah, and he certainly doesn't explain it. So you need to get in the habit of being able to see this or this from that, okay? And again, pay attention to that one, okay? Also, be aware that in college classes, a lot of times, you'll have a teacher that goes, "Hey, just take the log," and they will not say the natural, they'll just say the log. And so it kind of freaks you out sometimes because you're thinking log, L-O-G, but they'll use the natural log. And that's how it is. Just get comfortable with it. Be aware of that. So if you had this problem here, 7 to the x minus 2 is equal to 343 to the negative x plus 1. You're like, Groom, how do I do this problem? Do I do the log of both sides? Well, you can do it a couple different ways. I'm going to show you the easier way. If you are like me and you know your 7's powers, you know, 7 to the first power is 7, 7 to the second power is 49, 7 to the third power is 343. So that I can rewrite this as 7 to the x minus 2 is equal to 7 to the third to the negative x plus 1. This is a power to a power, so we should multiply our exponents. Right? Hey, if the bases are the same, what does that say about our exponents? They also had better be the same. So 4x better equal 5, so x better equal 1 and a quarter, I guess. And if you plug that in, you will get matching points. For instance, if you put in 7 to the negative 0.75, if you put 343 to the 0.25, whoops-a-daisy, Mr. Groom, you screwed up. Oh, negative 0.25, you moron. Oh dear, they're the same number. Now, that's one way to do that problem. Okay, another way you can do that problem, another way to do it is this way. And this other way will work for everything. This way here only worked because 343 was also a power of 7. But I could also just as easily have done the ln of 7 to the x minus 2 is equal to the ln of 343 to the negative x plus 1. If you bring that down, you get this. And bring that out front like that. Now the ln of 7. Get over here, stupid. The ln of 7. The ln. Well, I'm going to write this one. Well, no, am I? Yeah. I'm going to divide both sides by the ln of 7 just for fun, okay? And so if I do that, the ln oh, no, shut up. Well, no, you shut up. No, I won't shut up. Why did it work that way, Groom? Because what you're really saying when you do this, the ln of 343 divided by the ln of 7, what you're saying is, really, is you're saying, what is the log base 7 of 343? In other words, 7 to the what power is equal to 343. That's what you're saying. You are solving that equation. And so lo and behold, what I end up with x minus 2 is equal to 3, because again, this is 3, negative x plus 1. And you're like, dude, it's the same problem. Well, I know. I know. So the answer still better be 1 1/4. I know. Oh, it's x minus 2. I know. Of course it is. And it is. Okay? So a couple ways to get here. If you're not sure if 343 is a power of x, okay? If you're not sure, is it a whole number power of x? I don't mean is it the 2.7 power. Okay, what can I do? Is 343 a whole number power, which is what we just normal people say, a power of 7. And if that's true, again, what do? Well, I say the log base 7 of 343, of course, is equal to x. Or another way of saying that would be to do the log, or the ln of 343, divided by the ln of 7. If this is a whole number, then yes. Then yes. Okay, that's how you do it. Now, Grim, I don't know my powers of 14. I don't know what they are, Groom. Okay, well, okay, so what are you saying? Is 13,496 a power of 13? I don't know, but if it was true, that means that 13 to the x is equal to 13,496, and of course x would have to be a whole number. So again, I would just take the ln of both of them. So the ln of 13,496 divided by the ln of 13. Oopsie daisy. Well, they didn't give me 4, so I bet it's not true. It's not true. Do you see that? It's just not true. Okay. All right. Let's go over the rest of the rules here. We've already talked about the power rule. Let's just review it again. If you want the log base b of a to the r, that's the same thing as saying r log base b of a. What I mean by that is the power rule. Okay, you can bring that baby down front. Okay, we've already looked at a couple of those. Okay, what about the log of a, I should say base b, the log plus the log base b of q. What is that equal to? Well, it's the log base b of a times q, right? Whenever you're adding exponents, which is what's happening here, you're adding exponents, you are multiplying. Okay? Or, and say like Groom, try one. Okay, what's the log base 2 of 7 plus the log base 2 of 14? Well, it's the log base 2 of 98. Okay, well, is that true? I don't know. So in this problem, if I want the log base 2 of 7, it's 7. It's a log of 7 divided by the log of 2. And I get this answer here. Plus the log, I'm going to grab this and bring it down, edit it if you don't mind. And so when it's all done, I get 6.6. In other words, what you're saying is 2 to the 6.6 power better equal 98, and it does. That's what we're saying. Well, it's also true when you're minusing, except this the other way around. The log base b of a minus the log base b of q is equal to the log base b of a over q. Magooch. So when you're subtracting exponents, you're dividing. Okay? By the way, this one up here, by the way, this top one, the power rule, this is because, think about what this does for us here. This is just a power to a power, right? Because what you're saying is, if you do this part here first, because that's what's happening, okay? What is the log base b of a? I don't know, but it's an exponent. And what's r? It's an exponent. And what happens when you have a power to a power? Well, you times, you see that? You times your exponents. See, that's what's happening here. That's how that power one works. Okay? Good times. And again, change of base formula, I already said it, but I'm going to say it again. If you have the log base b, b of a, this is what we're going to say. We can change the base. This is equal to the log base r of a over the log base r of b. And again, most of the time we're going to write that as the log ln of a over the ln of b. Okay, that's what that says to us. Okay. All right, questions, comments on that? Oh, just fooling with you. Couldn't answer them right now if I wanted to. All right. So here's an example of a couple from the text, and we'll just play along and see what happens here. Oh, I want to do that one. No, I don't. Yeah, I do. No, I don't. Yeah, I do. The square root of 5 to the x is equal to 125. Groom, I don't know what to think. Is 125 a power of the square root of 5? Well, obviously, because 5 times 5 times 5 is 125. And obviously, 5 to the what power? 5 to the something power, I'm going to use a different variable, is equal to the square root of 5. this is obviously a half, right? M is equal to 1/2. How do I know that? Because the square root power is the 1/2 power. So what I could do is I could rewrite this as 5 to the 1/2 to the x. Are you with me? Is equal to 5 to the third power. So that's 5 to the x over 2 is equal to 5 to the thirds. But listen, those are identical bases. Therefore, the exponents must be equal. So x better equal 6. Which makes sense because we know that the square root of 5 times the square root of 5 is 5. So and I have to do it 3 more times. So 2 times 3 is 6. Yay! If you're unsure of this, a guy could always take the ln of the square root of 5, right? And then is equal to the ln of 125. Bring this feller out front. And if you divide, what you'll find is you get a whole number. And what did that tell me? Well, it told me 2 things, but primarily it told me that 125 is a power of the square root of 5. Okay, in case you didn't know that already. Yeah, right on. So the log base 14, no, I can't do 14. I do what I can do in my head. 4 of 4096. Okay, this is your problem. You're like, it doesn't equal anything. That's how the book will present it. I'm telling you right now, that's your answer. Are you with me? Now, again, this is how it's presented. This is how I do, because that's what I'm solving for, right? What I need to do is, this is logarithmic form. I'm going to put that over here to exponential form. So in other words, 4 to the x equals 4096. I need to get the x down, so I'm going to take the log of both sides. And then I'm going to divide by the ln of 4. Now, remember, if this comes out to be 5, that means that 4096 is a power of 4. But if it doesn't, I still get an answer. Either way, you with me? Oh, it's a whole number, which means that 4096 is in fact a power of 4. Does it still work even if it doesn't work? Yeah. Because even if this is 4097 and 4097, my plan's the same as 6.0, something else. You with me? But if the way you solve it is the same, that makes sense? Piece of cake, actually. Actually, a lot of fun. I don't know about a lot of fun. It's some fun. Okay. Here is another one that you will see on the assignment. 3 times 4 to the 1/4 power minus 12 times 2 to the minus 3/2. Nice. Well, we would like to solve this as a whole number without using a calculator. That's easy, right? So what is 4 to the 1/4 power? I'm not sure. But since this is a power of 2 here, this is also a power of 2. That's 2 squared to the 1/4 power. Are you with me? To the 1/4 power. Minus 12 times 2 to the 3/2 power. So far, so bueno. Okay, then, Groom, in order for me to do this, whatever this is here, has to be the same as this, right? Because otherwise, we're kind of screwed. And so then what is 12? 12 is 2 squared. 2 squared times 3. Right? Cool. So 3 times 2 to the 1/2 minus 3. And I'm going to write these side by side if you don't mind. I don't care if you mind. I'm doing it anyways. Screw it. Now what happens when I multiply? What do I do to my exponents? Why, I add them. Yes? And so this is 2 plus 1/2 is 3.5, which would be 7/2, I believe. So 3 times 2 to the 1/2 minus 3 times 2 to the 3/2. Right? No, not 3/2. Try again. 7/2. Right? And then simply a matter of, well, what am I going to do with this here? Okay, well, what do I have in common? Well, they've got they've got a 3 in common. I can factor it out. But they also have a 2 to the 1/2 in common. You with me? What is that left in here? Well, I got 1 minus, and now what's left? I took the 3 out. There's just nothing there. And then I take a half, x to the 1/2. I get x to the 7/2, or x to the 2 to the 7th power. And then, of course, 2 to the 7th, last I checked, is 128. So 1 minus that is going to be negative 127. Okay? All right. And so then it's simply a matter of, what can I do with that at all? Well, I don't know. So I can bring the 3 back in if I wanted to, I guess. That's about the best I can do. I multiply the 3 back in, and I'm going to get a 21. Carry the 2 is an 8. Wait. 381. Yeah, that sounds about right. 2 to the 1/2 power. And, yeah, pause. Okay. So I made a boo-boo. And so Mr. Groom's going to go fix his boo-boo, and we're going to figure it out together because it's for the children. Okay. Yeah, I think that's what I want to do. I think so. Maybe. I hope so. Oh, you see that negative went away? Did you see it right there? Did you see it? Did you see it? I did. Ha! I see it, you hippie. And then what is 2 minus 1/2? It's a half, for God's sakes, Mr. Groom. Whoa. Hey, that's the same as that. I know the answer is 0. I told you, it's stupid mistakes. 90% of the time. Stupid mistakes. Okay, here's another one that you might see. Just pay attention. Don't screw stupid things up. The log base 3 of y plus, I didn't hit shift hard enough, plus the log base 3 of y squared is equal to 14. Now what Mr. Groom sees here is we're adding, which means I could rewrite that as the log base 3 of y cubed is equal to 14. Well, this is, as you know, exponential form. So, I mean, try again. This is, what now is it? This is logarithmic form. Here is exponential form. Okay? Now, Mr. Groom would like to get this down to where I can work at it, but I don't need to do a logarithm because notice the y is down here, not in the exponent. So I simply take the cube root of both sides. And so I end up with that, or 3 to the 14/3 power. Now, to see if we're right, of course, a guy can always check himself. 3 to the 14/3. Make sure that's in parentheses because your computer knows order of operations even if you don't. So I get 168. It's a good, bad, indifferent. I don't know. But here's what I know. If I did this, okay, I could plug it back into here and it should work. Yes? And so if I take that, oh, no, don't go to sleep. Oh, okay, thank you. Sorry. So I said that this is about approximately, I'll write it down here, 168. Okay, point, blah, blah, blah. Okay, that's great. What I can do is this, though. I can plug them into here. So I can take the log base 3 of 3 to the 14/3. Now, in a minute, you're going to be like, Groom, that looks goofy. I know. Because some of you are very tempted, and I mean very tempted, to put in 168 point whatever. I don't want to do that. You with me? I don't want to. So I'm not going to. Wait a minute. The log base 3 of 3 to some power. Dog, those cancel each other out. This guy can come out front. And the answer is simply, what is the log base 3 of 3? It's 1. So I get 14/3. Same thing here, bro, except, check this out. This is squared, so I times those two. I get 28/3. I bring that out front. I get 28/3. Is equal to question mark 14. Well, that would be 42/3 is equal to 14 That's a big fat check marker-rooney. Okay? A couple things just to review quickly. The log base anything of 1 is 0 because b to the 0 is equal to 1. Okay? The log base b of 0 is, or of anything of 0 or of x. Well, okay. Of 0 is undefined, of course. Right? The log, anything in here, matter of fact, the log base b of a had better be bigger than or bigger than 0. Period. Better be bigger than 0. We're screwed otherwise. Okay? The log base b of b, of course, is 1. It's that easy because why? Well, b to the first power is b. Okay? That's what I got for that. There you go.